Start right away. Awesome. Cool. I really got to boost up. I thought I would be able to do one video every day. I'm kind of not there yet, but I really want to get to that point. I really want to get that point. I'm right now at the point where I try to write one quantum daily article a week because those help me settle a lot of these stuff that I've been exploring here as well with these, this thing here. Yeah. But I gotta move a bit faster. I love to be able to move faster, but it's just there's just so many things going on during the day, regular job and stuff like that. And um, anyways, by the way, I don't say this often, but if you ever feel like sponsoring this channel, just purely donating $1 a month or something like that, just feel free to go straight to Patreon. I'll just Google Patreon, uncertain systems, and you should find these. And I've been thinking about doing something a bit extra for, you know, just those who would like to support the channel a bit more. Kind of do a bit of something special just for the supporters. Um, Let me know if there's anything that you guys would love to be able to see. Sort of, yeah. I don't know, something that bring value to you. I'll be happy to consider that as well, because I'm thinking like I could do something that brings value to the community a bit more than just the videos, but I don't know. We'll see. So far we're having fun with these. So where did I leave last time? Last time I left where we kind of had these going. I think I was going through mentally the so this was these, and then I wanted to simplify, and I think when I was simplifying it was breaking. Yeah, and the reason it was breaking is because as I simplify, I don't know how to deal with the edge amplitudes. That was the issue. So this is what we have, and then these branches can simplify easily, right? I mean, we've got the multiplication right, I think, because now they're like 0.5, all of them. And some of them are even negative, so that's cool, because I think that is really, it's really what we want, what we would expect here, right? Let me open up Paint, professional as always. Paint open. Microsoft Paint, the best drawing tool ever invented. I'm kidding, obviously. So maybe I would just manage to get that a bit. What happened with this? Something with this. Okay. I for some reason have these adjusted to both screens, and that limits the amount of drawing space that I have. So I'm gonna have, but I think I can fix that now. But I have two Hotmarts, CZ and a CX, right? So we start with a 0, 0, then we go the plus plus. That is awful. I have to change the way this digital pen works, because I just the thing is, I get the two screens mapped into a really small area, and I should just set it up so it works on one screen. And then I get a 0 plus and a 1 minus. That's what the control Z does. That's what the hotwire does. That's what the initial state does. And now I get a control X, correct? Which, why I was doing that? What is this doing? So this is doing 0 plus, and this is then doing control X. So basically a why is it create? Why? Oh, the control X is sorry. The control X is the other way around. So it's controlling on this qubit. So it does 0, 0, 1, 1, and then 0, 1 minus 1, 0, and this minus is sort of goes to the amplitude. So it's 4 branches, and this is what I have here. So the branch that has the minus in here is this branch, by the way, which has the qubit 0 is 0 and the qubit 1 is 1. That's correct. Okay, cool. So awesome. But now I want to simplify these, and I can simplify these because I can connect this branch with this branch and this branch with this branch. This is actually a good example of phase keyback, because this minus is gonna pop up there. Cool. So the issue that I'm having is that in the simplify function and the recursive part, what I do, this is this one, yeah. So cool. Then I get the. So if the states are not equal, then I add them and multiply and sort of take down the amplitudes, right? And here, the thing is, yeah. My neck. So, I'm just not sitting right, I think. Anyway. So this is a temporal edge, right? So if I've merged the edges, because if not, I just ignore it. If I merge the edges, then the problem is that now I have a temporal edge, right? So let's say those are, don't have enough space for all this stuff. So if I take this one and this one, right, this merges into a 0 plus, but now I have like a 1 1 and a minus 1 0, right? And those still are like 0.5 of the edge amplitude. But this one, like, because now in theory, I should just renormalize them, right? So I should keep track of them. Should renormalize them in the sense that what? Like, so I have added them up. So if I add them up, because I'm simplifying them, I don't want to divide because it doesn't feel like that's the right thing to do, despite the fact that no, it shouldn't be division. What I'm talking about, like the multiplication that I'm doing is I'm multiplying the one from the state, the amplitude down to the state. That's not that's I should be adding them, and then I should just renormalize everything. And so that obviously is going to have a bit more probability because it just added up 2 of them. So I think that's probably what I should do. So I should keep track of, oh crap, then I should keep track of the edge amplitudes, right? I don't like that because it means that I have to either add another parameter to the recursive function, because at the end of the day, what I have in here is finally what I have edges, and for each edge, I have the qubits, right? So I have that kind of not transposed, but like flipped, because you have edges and here I have edges and qubits, and I have the other way around. So then you get these nodes, and then I'm adding these, and so yeah, because I think I'm gonna have to do that, because then I can keep track of all the amplitudes with the same keys that I'm using here, and I can use them to reconstruct the the actual edges and all that stuff later on. The create edges, exactly. You should give it a matrix with the amplitudes. Yeah. Okay, so I will do these. So unless 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 I don't delete the edges, and I just update them. You know, like I should just update the edges. Maybe that's easier if I just... No, but that's bad, because if I do have a lot of chains, so what I was just having in mind is like I can create the edges as I do the merging, but if I do like 2 or 3 passes and then there's a temporal edge that then gets just replaced and remerged by another edge, then I don't want to just create that garbage. So I think that it's fine the way it is. It's just I just have to give something called amplitudes, which is just basically I hate that this is what, like, I think I can return amplitudes, right? Because I want to return the simplified edges. Oh, I know. Unless what I return... Unless what if I... Thinking, what if I, instead of just having the states, but I would have to rewrite this. So instead of having instead of building, instead of building the, instead of just building these, why I don't actually build... I mean, that's convenient, because I have the index of the edge and the qubit. But if I would just build here the actual edges, and then no, I'd have to iterate all... I mean, I think I'm just too lazy for that. Simplify qubits. I think I just have to give it amplitudes. So I just have to give it so A will be amplitudes, and so what I will be doing here is A is also a dictionary, and so when I create the edge, So if the E is not in the keys and the qubit index equals 0, and then what I do is I do a E equals self edges E amplitude. So I just basically populate that with the amplitudes of the edges so I have them. And then I give the amplitudes to the simplified recursive. And so the simplified recursive is going to have A basically so M is the dictionary with edges and qubits, and A is dictionary with amplitudes. Exactly. And so yeah, and so what I do here, yeah, so I actually these is as easy as a E1 because I have the amplitudes, right? A E2 because I have the amplitude, so I don't need to get them like these. So that becomes easier. And and here I need to add an amplitude for these, right? Which is basically which is basically what? Okay, and now is what I'm doing is okay. So, but that's the thing. I think at this step I should take a look at all the amplitudes that we have. Oh, and I should normalize them, right? That's the problem. That's the problem. I mean, in the result, I just have the result stuff, right? So, um, mm, so yeah, but adding is not adding. The problem with adding is that they're complex numbers, and if one has a negative and the other one has a positive, you get a zero, and I don't want that. That's the problem. I cannot add them. I just cannot add them. Because the thing is, I lose the amplitudes because the new edge, right? Like I have, that's complicated, man. Like, let's think about these, right? So when I merge these, right, this branch has a negative amplitude. But when I merge it, this negative amplitude goes here. Like I'm multiplying it here and I'm multiplying the other one there. So technically the two branches don't have any more an amplitude associated to them. Oh God. Because that's the reason you get phase kickback, right? So you would get basically a 1 minus 0, 1, right? So it kicks back up here. Kickbacks up here. But I don't know how. So how should I treat that? Um, how should I mm, somewhat and somehow I need like I need to come up with one amplitude out of those, and it cannot be that I'm merging them. Especially because I just multiplied when I merge, right? I multiply the elements by the element that is different. I multiply by the amplitude, which already. It's like I absolutely don't know because I mean, what will be the resulting? Okay, let's do the following. Let's take this example, right? You still gotta have, like, it's just a simplification. So you still have to have the same wave function at the end, right? If I get rid of these, I mean, I'll try to replug that maybe. It will just work for. Oh yeah, thanks God, now it works better. Now it just plug. Now it's just attached to the main monitor. Okay, cool. So if I but now it's not doing what I wanted to do. It's not actually painting. No. You see the pointer? It's not actually painting. Ah, come on. Can I quickly fix that? Why? No, I can't. I think I can't. Whatever. What I was trying to say is that. Oh, wait, something's wrong with Paint. It's just not responding or something. Oh, come on. I'll close Paint. Ah, Jesus. I'll just pause the recording for a second. Okay, we're back. See if now this somehow works. Okay, now it works. Looks better. Not feeling super confident with it, but okay. So we were in the state 0, 0, then we were in the state plus plus, then we're in the state 0 plus, 1 minus, and then we're in the state with the control X 0, 0, 1, 1, 0, 1, and then 1, 0, and this branch had like a sort of a -1 as an amplitude, right? The other ones had like, maybe it's not a -1, it's like a minus 0.5, minus 0.5, to be honest. So the thing is, this is 0.5, 0.5, 0.5, right? So let's say that now we want to merge. Let's merge these two, right? So what we're going to do is we keep the 0 and 0. We keep the 0, 1. And then we have a branch that is basically a 1 and then 1. Okay, you see, but that's the problem. Or no, that's okay. So it'll be 0.5 and then so minus 0.5, right? No, plus 0.5 because we're multiplying the 0.5 here, and then we're saying 1 minus 0.5 through the 0, right? But we normalize that so we get what we want, which is the 1 over the square root of 2. So this means actually this is 1 over the square root of 2, so this is rather 0.707 blah blah blah, right? So we have this here, and it's all merged into one. Sorry, so it's 1, and then this stayed. This is also 0.707 or whatever, right? Like 1 over the square root of 2, and not like not 5 and not 5. Now, okay, let's just make the numbers, right? Like what I should see from these is that I have basically, I still have, so I have the following wave function. I have like a 0, 0. I have like a, let's assume that's the rightmost, the leftmost, so 0, 1. And then we have the basically 1, 1. 1, 1 minus 1, 0. This is what I have. Now, what are the, so if I just cheat and go to Quirk, this is lagging, and I don't know if this is not this damn pain, man. If I go to Quirk and I quickly create this puzzle, Control Z, and then I do Control X. Zero, 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 one, but then again minus 1, 0, and 1, 1. That's it matches, but they're all still equally the same, right? But for these to be equally the same, it means the question is how, okay, so if I think about how would I reconstruct these, right? How would I actually construct the wave function is I would take this is A, this is B, and this is C, and this is D as being the amplitudes, right? So I would take A and do like, whatever, this is just 1 cat, like 0, 0. B is just 1 cat, right? So this is all match, because this they didn't change. They're still 0.5, they're still 0.5, right? But now here I know that C and D must be 0.5 as well at the end of the day, 0.5. So, okay, D must be minus 0.5, right? And if I have, but if I have, okay, so if I have these, which is a branch that says 1, and then I have 0.71 minus 0.7, Jesus Christ, this is bad, 0, right? And I just multiply that, what I have at the end, right? If I want to, it's just, I take that as a local, as just a system, and I just try to build the case out of these. Well, basically, I would get like 0.711 minus 0.7 1, 0, which is not what I want, right? Because I want 0.5. So this means, oh, it's not CD. What's more, this is just like C, right? Like, so this is what I get. So what we have, so what I have to get is, okay, something that times C and then times C, right, would give me these, would give me, yeah, so basically C times zero point 0.7 must equal 0.5, which means that what I have to do, interesting. Okay, so I have to take the previous amplitude and divide it by the new one, which is normalized. So, this would give me, what's that? So, yeah, pulling out the calculator. But those are complex numbers. Can I divide complex numbers? I don't know if that makes sense. I guess so. 0.5 divided by 0.7 is, yeah, something. It's like 0.714 or whatever. It's something, which I don't know. I guess, yeah, but I guess that's the way it has to be. I don't know. We'll see if it works or it doesn't work. We'll see. I'll close that. So I have to take the, did I say I have to take the, at the end of the day, I just realizing the amplitudes at the edge level don't mean anything in terms of they just don't have to sum to anything or anything. It's just they just help. It's really the part of it that you can it's sort of the part of the phase somewhat that you can factor out. I mean, so I just need the previous it's the previous amplitude of the edge divided by the new one, which is normalized. Or the new, I mean, basically the new one that they have, right? So these values, okay. Uh-huh. So these values, that's what I have to do. Hmm. Mm. It's a bit more complicated than that, isn't it? Because this might just be something else. Like it doesn't have to be 0.7. It can be point, it's I mean, this is originally, if I think of this originally being, so we've merged them, and yeah, it should be straightforward. So it's a value. Let's call this C and D, and let's call these like E, right? So E should be basically kind of this 0.7, I don't know how to call this, but this is the C times this amplitude that used to be in here, right? So E is like, how am I going to solve this? Because essentially these could have two separate amplitudes in here, and now I need to factor something out of these, right? So in a sense I need to find, it seems like this should be easy, but I'm just like, so this is C and this is D, and I don't know if I can just call that anyhow. C times, whatever I call it, alpha divided by, oh wait, I think I'm getting confused myself. I'm just getting confused with the labels. Let's do this properly. So let's give things proper names, okay? I think now that I know that I don't have to care about the whole system, it's just an isolated case, right? So let's try to do this. So I have, two branches, for example, right? And they are like these, so they can merge. Now, these branches have, say, an alpha and a beta as their amplitudes. And these guys here have an amplitude that is like, I'll call it alpha 0 for qubit 0 and beta 0 for qubit 1 for qubit 0, right? And so now they merge into one branch, right? Which is basically alpha times alpha 0 prima, because it's normalized, plus beta times beta 0 normalized, right? Times 1 and times 0, right? And so, and now we have a, like a mu, I just am bad at Greek letters, or I'll just call it x. And so we want these x, what we want is that, because that's the thing, I think alpha 0 and beta 0 should be 0 always. That's the point. But they don't have to be. So then this means that basically yeah, and we've just and what have we done here? Oh, this is complicated because I just realized I have another mistake, which is I also have to normalize them. Like if they're not equal, right? But then it's locally just 1, the amplitude. That's the problem. How do I know that I can take I should to be correct, I should just add a normalize, but without multiplying by these, right? So I only multiply by the amplitude when the elements are different. That's where I put it. But that's still something that needs to happen. And so, to be honest, this is and this is basically alpha 1 and beta 1. Cool. And so here I have alpha 1 plus beta 1 normalized. And so at the end of the day, when we rebuild the whole thing, what I'm saying is that, x times alpha 1 plus beta 1 normalized times alpha 0 plus beta 0 normalized equals alpha times alpha 1 times alpha 0. So this is one equation, and the other equation is the same but with the betas, right? So x times beta 1 plus alpha 1 prima times what did I do here? Alpha times alpha 0. Jesus. I'm having a hard time drawing anything today. It's also really laggish, and I think that this is so. So this is actually should be. It's so bad. Alpha times alpha 0, right? Because that's what we do. The merging is we multiply this guy with this guy here. So, and what I'm saying is that at the end we should have this equality. So we should say that if we multiply x by alpha times alpha 0 normalized times alpha 1 plus beta 1 normalized, right? That these should be the same like what I would get here. And if I do x times beta 1 plus alpha 1 normalized, let's keep it 1, times beta 0 normalized, it should be also should be beta times beta 1 times beta 0. So I should find an x that fulfills these two. And so I should find an x that fulfills these two. And if there's no such x, does it mean that we cannot merge? Maybe. How do I do this? So do I have access to these numbers, right? So yeah, kind of, right? Because I have alpha 1 plus beta 1. This is this sum here. Hmm. Of whatever. But this has happened. So I'm comparing two edges. If they're the same, then I sum them up. For n, okay, so that is it's just qubit one, right? Yeah, qubit. That's this n is the qubit. It's a bit misleading. Then I add them up. So I actually have these because if I'm here, then I have the nodes and I have all these basically, right? So I have this value. I have alpha. So I have these. Okay, but I don't. I have the whole thing. I don't have the whole thing decomposed because it's basically here. And here I also don't have these decomposed. Um, mm, and then I have the original. I mean, the thing is that just has one solution. So either there's such an one x or there's no. I think there's no multiple values of x that satisfy these. Right, so I can calculate one and then check if it works for the other. And if it doesn't, then I think I just shouldn't merge the edges. But I don't know in what cases this can happen. So, but how do I do this? Okay, so I'm iterating. I have to think too much. I have to think too much. So I'm iterating over the nodes and just adding them a lo loco, just like, just adding them. If they're different, I also multiply this stuff, but if they are not, then they are not. So could I calculate? I cannot, because here I'm going node by node. Here I'm going node by node. But I have E1, I have E2, so I do actually, in theory, still have access to all these, right? I have access to M. Okay, but I don't have access to the particular qubit. Well, I do because I can iterate over that again. For N1, right? So, because what I'm trying to get is I'm trying to get alpha 1 plus beta 1, right? I don't know how to get that. I mean, I've lost. I'm just not thinking. Um, mm, I am not thinking. Can I not just... Okay, can I not just factor something out? Can I not just find... Instead of doing all that, can I not just say, look, is there a common factor that I can just take out? Probably. But they've been normalized, and they've been normalized, and I don't know. I don't know if it's the same, because the thing is, they still gotta have the I still want them to have this 0.5 at the end. Can I not just say, well, I have this number and I have this number, so if I multiply, I mean, yeah, of course I can. No, how do I do this? I'm trying to find a more intuitive way to do this. Should it just be... I'm feeling so dumb now. So here we're having access to each of these, so we're multiplying them and we're adding them. So if I'm multiplying them, this is this alpha 0, alpha 0 normalized. Yeah, that's the problem, is that here is split and here is not split. What if I don't normalize this? It's not, I know it's not alpha and beta, right? That's the thing. Even though because what I should do is actually the easiest way. The easiest way would be that I expand these, right? That I expand this. This means that I take the that I multiply the two complex vectors, and that then I expand uh, these two branches and add them up, right? Exactly. If I expand these two branches and I add them up and I expand this one, they should be the same. They should give me the same complex numbers overall. Right? Mm. But in a way, I cannot find. But I just can't. I just can't find that because I can't just divide the arrays or something, right? Uh, you know what I mean? Like these kind of gives me, you know, this gives me like a state, right? That if it's added with to this state, should give me basically this state, right? Um, and here now we have, and if that's not the case, and you know, and this is kind of like actually alpha better, and then this is the x here, right? So look, maybe that's a better way to do the merging, isn't it? Isn't that a better way to do the merging? Instead of doing that, I build a complex number. Hmm. Yeah, no, but that's not the point because then I get a that then I still get like a bunch of branches here. That's just the presentation of branches. So I just want to somewhat solve these and find x, right? Because x is sort of the common factor for these whole thing. So that's the equation that I want to solve, and I have everything. Okay, but that should be solvable, right? I have alpha, I have beta, I have these, I have that, I have that, right? So that's what I want to do. How do I do these, though? How do I uh, how do I program? How do I find x? Because x would just be these plus these, and then divided by the array, right? Which is not um, which is it's definitely not like, I mean, can you divide matrices? Uh, uh, you know, you know, maybe it's just multiplication of the conjugate. Mm, can you matrix complex numbers? Two complex numbers. It's like that is a problem already in and of itself, like the actual division of the complex numbers. So I probably shouldn't do that. Um, That's the thing. These are complex numbers, and I'm not gonna divide. Does Python even support that? Division. Division. Okay, whatever. Well, you can do that. You can do that somehow. I'm a bit lost. I'm a bit lost. So how do I calculate that? It's a number. Yeah, I guess I could just do it this way, right? I can just hope that NumPy knows how to divide these, and basically take alpha times alpha 1 times alpha 0, which I have, and divide it by alpha 1 plus beta 1 normalized and alpha 0, which is this one. And then do the same for the betas and hope that it works. So oh god, but I should keep track of these because I cannot just get them. So alpha 1, so these are the qubits, right? And the problem is I need to know, I guess I need to know what qubit is the different one. Because the thing is, I need to iterate. This can be, of course, I can have n qubits. So I need to know. Okay, ndiv is n. So I need to know which one. I need to know which. I need to know. What am I doing? Semicolon. Which element is the one that is different? And so what I need to do here, in order to calculate the amplitude, is so for each of four for n in nodes, right? So for n in nodes, I need to multiply. I need to multiply alpha, right, times alpha 1 times alpha 0. That is kind of okay. What I need to do is, so that's kind of all fine, I think. No, that's not all fine. What I need to calculate is, I don't know what I'm calculating. It's just so hard. I'm iterating over the nodes. So like these and like that. Exactly. So what I need to calculate is I want to calculate the alpha times alpha 0 normalized. Because I should go, I'm iterating like that. I'm iterating like that. So okay, so if the qubits, yeah. Okay, so I need to multiply, because I guess this part here is something that is what kind of goes here, right? And you need to multiply for all those which are equal, and then instead of multiply, and then multiply for the zero component of the one that's not equal. Yeah, so okay, so wow, so I'll just let's start with z being 1, and then cool. So if n equals and if, then what you do is z is equals z times just the zero component of it. So nodes n, right? Zero component of it, which is a complex number. Else z equals z times the whole number. Yeah, the thing is, if it's a 1, so it's going to have the 0 component and the 1 component. That can be, in general, everything. Oh, Jesus Christ, that is not good. Because that can be a plus state, right? And so the plus state will just also have, oh, I'm messing up too much. This can be, yeah. No, why am I doing this? It's not the 0 component, but it is whatever I merged before for node 1. I just don't have a nice way to know this, because it's basically these and that. Maybe I just should call these things, I just should not feeling really confident with this. That doesn't feel like it's something that makes sense at all. Maybe I shouldn't. Maybe I just shouldn't normalize that. No, but I have to normalize that because Maybe I should normalize that, but I really have to because otherwise it's just messy. But this got to be normalized. Oh. Why isn't these a function of alpha and beta? Because what I'm saying here is I'm saying that I've added these two I've added these two amplitudes, which are they are complex numbers. These are amplitudes which are complex numbers. Let's keep that in mind. I'm having a bit of a problem now with just mine. Okay, wait a second. So these are amplitudes. No, it's a state. Yeah, but they are amplitudes, right? They are arrays of amplitudes. That's the thing. And this is just, and this is this is like a complex number. This is an array of, it's an array of two complex it's an array of two complex numbers. This is also an array of two complex numbers, right? When we merge them, we add them because they're different, you know. But if this would be a plus, then this would be a minus, right? The addition here, so you would have like 0.7, 0.7, 0.7 minus 0.7, so things would cancel. So things would cancel out, and you see multiplying by these, and so you get the right thing. You would really see interference there happening. But how do I call, like, what is then, what is x? That's the problem, is what is x once I merge two branches? Because x should still be somewhat a combination of alpha and beta. Something tells me that this is the way it should be, but it doesn't have to be this way, because at the end of the day, what you have to have is you have to have at the end you have to be able to decompose that into a wave function that where the values match. And so am I being that stupid? Am I being that stupid? This is not an amplitude. This is it's an array of two amplitudes. Let's see if I can. We can start from scratch here. So we have two edges, right? We have that's the problem, is that we don't have these. That is the main issue. We just have states. So we have, yeah, we just have states. At the end of the day, we just have states. That's just the wrong way to seeing of seeing this. So here we have a yeah, I'll just call him A and B, right? And then uh, we have C and C, right? So this is kind of what we have. These two are equal, and then here we have we'll call this X and Y, right? And so at the end we get basically a sort of a D and an E and a Z, and we know that E equals A plus B normalized, call it and the n function. D equals, oh, not only that, it's X. Okay, let's get this right, okay? Let's get this right. So E equals the normalized, basically, X times A plus Y times B. D equals normalized I mean, again, it's C, right? It's just, as we know, it's C. If you add C twice, if the state is the same, if the state is the same, I mean, that was okay, I think, because that is just a state. And the state, we just check the state is the same, so we keep the state. I got really distracted because of, I got confused with these, you know. So it's really C what you get. So D equals C. And so we're looking for what is Z. So we know that E times D times Z. The thing is, X, Y, and Z are complex numbers, and A, B, C, and D are arrays. E times D times Z equals yeah, basically A times X times C plus C, that's an X, next, times Y times B. We know that D is E, so this is E squared. This is E times Z is so maybe the division is I just divide the arrays, the array elements. I don't know. because, and then I have x a c. So I have E, I have as well, right? It's and so I have so E is normalized x plus a, x times a plus y times b, normalized. Because I would have to just z is would be literally a times x times c plus c times y times b. I can see that, okay, so this is e squared. I can take c out of these, and it's ax times yb, but that doesn't make any difference. C divided by e squared doesn't make any difference. Now I think we can just, so z is like this. The thing is, how do I divide? Um, in essence, it's a matrix, right? Like, what is matrix division? Can I just do, can I just, exactly. So you can multiply, maybe I just have to the, if b is invertible, then you can do a times the inverse of b, exactly. And isn't that, if b is invertible, the inverse of a is given by this. NumPy inverse array. The inverse of matrix is a matrix. The inverse. I can just use the inverse. So this is the just basically the inverse. Can multiply that by the inverse. So this would be, and those things should be invertible, right? I think they should be. So it's just minus 1 times e minus 1, and so it's like e minus 2, right? And then times this whole thing, and that should be z. So I have, okay, so I have these numbers. I think I have everything. So do I have everything? So if I, let me put that aside for a second. So okay, so I'm here and I have the nodes, and I need A, B. So I need A. How do I extend that to more qubits? Basically, there's going to be just one different, that's C. And then everything else is just, I need to do X times A times, everything else, right? So A is really just, it can be a set of qubits like hidden in there. So I can just probably I can just probably keep these variables here and just say A, B, C. I think I can just define A, B, C, A, B, C, X, Y, D, E, and Z, and they'll just be none, right? And what I do here is, so if these are different, right? If this is different, then I'll just say, well, then C is basically not different. Sorry, if they're different, right? I know A. Okay, so here I need to keep computing that. So I think A, B, and C, X, Y, and Z. So A. Okay, I just don't know. Okay, so what I just should say is if A is none, then basically A equals this one, else A equals A times this one, right? So we're multiplying each, and we're accumulating them all. Exactly. The same for B. So B, 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 but this is edge 2, right? So this is edge 2. Then if they're equal, it's C, right? So we basically say C equals this. And if it's something that's not correct, then we'll just lose all this data that's all correct. So I'm getting A, B, and C is all these, right? D equals C, so I don't really care about D. So D doesn't exist. The thing is E. So E is just gonna be okay. So with E, yeah, E is just these. What I'm doing here is like now I'm calculating that, and I'm saying the same for E would be if E equals none, then it's this one. Then we initialize the value. Otherwise, B is B times this one. Right? So we keep multiplying these results. Cool. So if something like that would work, I'm just like, yeah, sure. Cool. I'm reading what I just wrote in here, just you don't see because it bothers me in the screen. But I should just probably keep it here. So Okay, so I've gotten these variables in here, and so what I should do now is I should at the end just say, well, the amplitude of the resolving thingy should just be this is Z, right? So I need to get the inverse of E. Oh, sorry, if E is known, E. And so here I need to say, I need to get basically inverse E is like NP linear algebra inverse of E. I don't know if that's doing the right thing because these are arrays of complex numbers. And so I now need to just do what I calculated here, which is basically that this guy here is, well, it's in E times the inverse of E times A times X times C plus C times Y times B. What are X and C? Sorry. So X and C are basically yeah. Actually, X is these, and Y, X and C, X and Y is this. So we have these things here. Okay, cool. Yeah, I'm sure that's not going to work. Print these. So, okay, so I'm basically calculating all these elements in here, and I'm just at the end saying, well, that is the amplitude of the merged thing. This is the amplitude of the thing that we've merged. But am I missing anything here? Is this really going to work? So if the NDiff is NBDiff is below or equal 1, it's not. Yeah, it's below or equal 1. The thing is, I'm not so sure if I can merge both cases. You know? Because if NBDiff is 1, then we do all this stuff. If they're equal, they're equal. We just get rid of 1. Okay, but you still, if NBDiff is 0, that's the problem. Is that then we're not gonna have C defined, right? Then we're not gonna have C defined. So I think I'm gonna keep it like that. We're missing the case where NBDiff equals 0. So this case we're missing definitely. We got to treat it differently because the amplitude treatment is going to be different. So all this kind of stuff is different. Yeah. Okay, cool. Yeah, let's see what happens. So let's check that still works as expected. And now let's try to simplify. That's just going to break. Yeah, I assume so. Cannot unpack non-eatable. Oh, okay. I thought you could just define things like these. Oh, maybe A equals none, B equals none, C equals none, E equals none. I don't know if there's a better way to do that. I'm just like bad at these. That's no problem. Subscriptable. Oh, we have an A already there. Okay, let's call these amps. Let's call these amps. And then this is amps, and this is amps, and this is amps, and this is amps. And this is definitely amps. Yeah. Amps is not defined. Yeah. Amps. And so we build amps in here. Yep. Okay. The truth value of any array with more than one element is ambiguous. Use any for... Okay, maybe I just should... I should initialize these as the identity. The truth value of an array with more than one element is ambiguous. Maybe I should just use length. If the length is 0, maybe I can just use that. Because length of none is probably 0, so I can just say... I can just probably say... and get done with these. This is B. Length of E. Of non-type has non-length. Oh, okay, non-type. Maybe I can just... Can I just check the type? So check Python. Check if type non-type. Can I just do that somehow? Is none, maybe, okay. Oh, okay, cool. So maybe I can just replace all these ones here by is none. That's what I should do. Okay. Okay, but now we have, okay, fancier thing. One-dimensional array given, array must be at least two-dimensional. For the invariant or what? Yeah. Why is it one-dimensional? Oh. It's just E. Okay, so no, but E is not one-dimensional. E is multidimensional. I think I got the wrong E. Okay, just had to pause for a second. So why is that that this is one-dimensional? Yeah, that's the thing. Okay, so it's an array. Because I should transpose all of these. Because there should be matrices. The column, that's the point. There should be column vectors. Like, no, it's not that I have to transpose them. I just have to reshape them. It's just, I think I just have to reshape them. New shape. Instead of just being 1, 2, it's just going to be 2, 1, I think. Three rows, so we want 2 rows, 1. Okay, so 2, 1. So they need to be, yeah. So when we do this here, so this needs to be NP reshape 2, 1. NP reshape, right? 2, 1. NP reshape 2, 1, and actually that applies to this one as well. So just because, yeah, they need to be, for these to work out, we really need to treat them as column vectors. Just, yeah. And the same with C, isn't it? This, yeah. 2, 1. 2, 1. If that doesn't work, I'll stop here because it's almost a 2 fucking hours video. Okay, but maybe, is it one-dimensional? Is it? It's not. I mean, I've reshaped these things, right? E. Okay, that's the thing. I don't think that is that a multiplication? What I need to do here? That's a question. Like I have, because I have, so if I have A, B, and C, D, and then I have, yeah, that's okay. I should have A times C. And then B is like C plus A times D. Yeah. Okay, no, that's still these. So should I maybe print? Should I maybe just print this? Here, so print C, D, and E. Why, there's something not being saved properly? Or am I not running the... Why isn't the... Why isn't the print line being shown? Oh, syntax error. I didn't see that. Uh, there you go. Ah, okay. Word must be string, not int. Okay, I think... Can I just print E? What's the problem? Not int. Okay. What's wrong then with... Okay, let me just not print these for a second. Something else happened. Okay. Something's really off here. I'm also the mouse, I think, just running out of battery. Simplify recursive, simplify. Type error. Order must be string, not int. Get attribute. Where is this happening? Is this happening? Is this happening? Let's try one thing. Let's just not do the actual multiplication. Okay, so let's just not do these. And let's print E at least. Ooh. So I haven't done the multiplication. So what is the... Is it happening in here? No, it's happening. Order must be string, not int. I don't know if it's not from numeric. NumPy. Reshape. Array-like and new shape. Int or tuples of int. And I'm getting order must be, I think this is the, must be string, not int. So I think it's this reshapes thing. So what is this here? That's the first thing. that I should do is, I think that's the problem. But I think I'm gonna drop it. I think I'm gonna stop it here because it's too long a video already. Okay, that's not an NumPy array. That's the reason. If I do, and I give it a, was like D type or something, NumPy complex arrays. I'm gonna drop these because I think Paint is making things go slow. D-type complex, okay. It prints the same, so I think maybe there are indeed NumPy arrays. So let's see, where does it happen? So if I comment on those, I guess now nothing's gonna happen. It still happens. Simplify. Again, sorry. So that happens, yeah, with the reshape. Reshape ordinal string not in. What is this? What is this? NP reshape. Let's pass the shape tuple as a second argument. Oh, it's a shape tuple. It's not. Oh, okay, I get it. I have forgotten about it completely. Not that I use it a lot, but okay, so it's a shape tuple. I get it. B. So my mouse is just, I think my mouse is losing it. This I should use the trackpad. I think I'm just losing the battery. It's a tuple. That's probably the reason this happens. That's good, because actually I have gotten some of these, so that's actually not bad. Okay, so let's think about this for a second. So if it got all the reshapes done correctly. Oh, okay, cool. So it's done something. Huh. Okay, so it's actually calculated something. Cool. print E, but it hasn't done the inverse. And we print these. Let's see if that works, man. Last two dimensions of the ray must be square for the inverse to be. So it's not invert. I cannot invert. Okay, I cannot do that. I cannot do the inverse. Why I cannot do the inverse? But it can multiply. Can I just multiply by the conjugate transpose? I don't know. I think I just have to transpose this, but numpy transpose. I don't know if that's gonna. I don't think that's what we want. I gotta figure out how I gotta be able to do this. It's just NP transpose self. It's not. It's definitely not. I don't think that's what we want. That's what I thought. Only integers, slices are valid indices. We're doing something. Wrong here, are we, or what? Yeah, I gotta figure this out next time better. I think I'm not gonna. I think I'm not gonna figure it out now. It's just too late. It's 2 hours video. I'm definitely gonna stop. Nobody's gonna watch these anyway. Yeah, it's not that trivial. I'll give it a thought. I'll try to think about this a bit more. But it's gonna. I think I'm not in the wrong. Yeah. I don't know.